Okay, I'm on section 14.3a, and we're looking at problem number 4. It says in the following figure, the smaller triangle is the image of the larger under a dilation centered at point O. Find the scale factor in the length of X and Y as pictured. So let's first of all recreate this dilation in GeoGebra. I'm going to start with the triangle. With sides 15, 10, and 13. And we're going to dilate that with the center of dilation at point O, out here. But what else do we have to know before we do a dilation?
If they are similar or congruent, right?
Well, it will be similar. If it's a dilation, we know it'll be similar, and that's going to come into play here. But before I tell it how to dilate this, what do I have to know? What goes into
Oh, your scale factor.
the scale factor? So we'll dilate from the point, we'll highlight the triangle, we'll highlight our center of dilation, but what is the scale factor from this picture? Can anybody tell what the scale factor will be?
Was
I'm
it
sorry, what number are we on again?
4.
4.
You just,
Well, I mean, we
you
solved
have
it.
the box over it, so we can't see it.
wasn't it 2/5?
Yeah, it was 2/5 is what we came up with.
Yeah,
Yes,
4 over 10 and then
a side of 10 that goes down to a side of 4. So we need to multiply by 4/10, which simplifies to 2/5, in order to bring it down to the smaller figure. So this one here was, this side here was 4. So that's how we knew that the scale factor was 4/10, because we've got the smaller, the image was 4 and the original was 10 with these 4 corresponding sides, BC and BC prime. And now we have this side is a length X and this side is a length Y. And we'll use that scale factor to set up a proportion with the other side lengths, because somebody already said it. We have similar figures under dilation, so we can just set up a proportion with the side lengths.
Dr. Knapp, what made you know to put the smaller number on top?
Because
For
we're moving from a large figure to a small.
Well, then that would make me think to put the large, if you're going from large to small, I would think put large on top and small on bottom, but
Well, if you did that, if you have a large number on top and a smaller number on bottom, that's going to be more than 1, greater than 1. It's going to enlarge your picture.
okay, that is the,
Now, think of like
I just needed to hear you explain it.
you know, like on a copy machine, if you're taking something with a greater than 1, like if you're doing 150%, that's times 3/2. But if you
Yeah.
got smaller, you have to multiply by a fraction that's less than 1.
I have a real problem with copiers, so
Like if you took it times 2/3, your copy would get small.
smaller.
Or in this case, times 4/10, 2/5.
Yes, okay, thank you.
Fill in the proportion for me. I have 4/10 would equal X over what?
13.
15.
I mean 15.
15 or 13?
15.
15.
because it's a corresponding side. BA under dilation became B prime A. And then setting up the other proportion, we would have our scale factor is still 4/10, or you can write it as 2/5. Would be the
Y over 13.
Y over 13. And then if you did that calculation, 4 times 15 divided by
It's 26 over 5.
26 over 5.
Last night we did it times 2 over 5.
4 times 15 is 60 divided by 10
Yeah, so it's X equals 6, right?
is 6. And then the other one, 4 times 13 divided by 10 is going to
That
give
gave
Wait, what? Hold on.
that gave us 26 over 5. But last night when we did, or Tuesday night when we did it, we multiplied them by 2/5 instead of 4/10.
we use
Okay.
the simplified version here of 2/5 equals Y over 13. You would get the same answer. You just have to simplify this. Any other questions about that one?